Good afternoon. Good morning. Welcome to the AI Technology webinar. Formal coding, modern challenges demand new solutions. See why not all conformal coatings are the same and why AI technology has taken on the challenge to create new types of conformal coatings.
All right, thank you for the introduction, Maurice, and thank you to everyone joining us today. I'm Robert Gelosa, and I'm a sales engineer with AI Technology. In today's webinar, we'll be discussing the challenges facing today's conformal coatings, the attributes that contribute to meeting these challenges, and also discuss two new types of coatings by AIT. We'll start by discussing the challenges, then discuss the properties that must be addressed and balanced in designing conformal coatings, and take a look at the new coatings by AI Technology. So what are the challenges? First, let's look at the traditional challenges. Across various industries, electronics must operate under harsh conditions. These include environments filled with moisture, harmful gas, and industrial pollution that can cause corrosion of electronics. In addition to corrosion, electronics operating in salt fog and salt spray environments face impedance issues and short circuits if the coatings supposedly protecting them become overly contaminated by ionic particles. Conformal coatings must also be able to withstand and provide continuous protection even if there are massive swings in temperature. Today, conformal coatings face more challenges than ever before, and they continue to grow. Electronics are used more in outdoor environments. Modern cars are filled with electronics, passive safety systems, driver assist systems, infotainment systems, all of these requiring more and more ECUs. Autonomous vehicles are equipped with many sensors and cameras, including moisture-sensitive optoelectronics like LiDAR. These automotive electronics must survive in all climates, weather conditions, and environments. The IPC set the standard of testing for a conformal coating. IPC CC 830C sets the bar and covers protections against basic environmental factors, as well as testing for electrical insulation. But for today's electronics, conformal coatings must go beyond traditional protection. We use more wireless communication than ever before. Electronics have higher bandwidth and higher frequency with components in closer proximity, creating a greater need for protection from ionic migration, especially in salt environments. Smaller and thinner sensors, actuators, and controllers allow engineers to position them closer and closer to the heat source and into corrosive environments and into the conditions they're trying to measure. With the Internet of Things, IoT, people can put electronics into anything they can imagine, but then they must be protected. Our smart electronics and AI systems have more stringent reliability requirements than the electronics of the past, especially in critical applications, for instance, in self-driving cars and medical monitors. Better protection is needed for these than the traditional protection of the past. AI Technology, Inc. has been a pioneer in advancing specialty applications, and we have the expertise to meet these challenges. Let's take a look at a better way to think about conformal coatings. So there are 5 traditional types that everyone uses, but given the advances in technology, new solutions are needed. And IPC CC 830C does allow for new types, and later in this presentation, AIT will introduce two new types of conformal coatings. All of the attributes listed here matter in selecting a polymer or a coating product, but each property taken alone should not be the determining factor. Designing and engineering the right coating takes a delicate balance of all of these factors. AIT has taken each into consideration in designing conformal coatings. First, let's look at hydrophobicity. So hydrophobicity is definitely a desirable property in conformal coating. We want water to just roll off. Have you ever done a water drop test? Just put a drop of water on a surface. If the surface is hydrophobic, we'll see it ball up. But if it's hydrophilic, we'll see it spread. So hydrophobic coatings repel water, and they may even be suitable for short-term water immersion. But many users of conformal coating mistakenly conflate hydrophobicity with total coating protective performance. On its own, hydrophobicity is not enough. Next, let's take a look at water absorption. Low water absorption is an important factor. We don't want a lot of water sitting in our coating, easily accessing the interface between the coating and the board. That said, low water absorption alone is not enough to provide the best protection. So acrylic and silicone are used by many people in the electronics industry. They're well known, so let's compare. Generally, acrylics absorb much more water than silicones. But at the end of the day, acrylics still typically provide better protection than silicones. It's because despite being more hydrophobic and having lower water absorption, silicone has a much greater moisture permeability than acrylic. So here we see the water absorption for a few common materials used in our industry. We see that acrylic and polyurethane are about equal, with epoxy absorbing even more water. Also highlighted in this chart are two new conformal coatings from AIT. As we design them to balance all of the relevant properties, they have very low water absorption. So many conformal coatings out there address the issues of water absorption and hydrophobicity, but moisture barrier properties are largely neglected in the industry. The moisture permeability, or transmission rate of water in its gaseous form through a conformal coating, is a reflection of the molecular structure of the polymer. Greater free space volume and larger pore size will lead to higher moisture permeability. The moisture permeability is also dependent on the temperature and the thickness of the coating. In many polymer coatings with low TG or glass transition temperature, such as silicone, the free volume is high. Polymer coatings demonstrate a greater increase in free volume and pore size as the temperature increases above TG. One of the most significant challenges in the molecular structural engineering of conformal coatings is creating a flexible, low TG conformal coating with small free space and pore size. This is exactly what AIT did in creating our new conformal coatings CC7130 PRTC and SC7130 CC. The oxygen permeability and moisture permeability of various polymers are mapped on this graph, including for typical acrylic and silicone conformal coatings, and AIT's CC7130 PRTC and SC7130 CC. Even the materials we trust our food and drink to have equal or worse permeability properties than coatings by AIT. Another topic intricately related to moisture permeability is the diffusion of harmful gases through a coating. The molecular structure of conformal coating and the pore size is key to the diffusion of gases through a coating. The diffusion of any gas through a coating is dependent on the Fickian diffusion coefficient, the thickness of the coating, and the temperature. An instinctive assumption that you might make about gas permeating a coating is that smaller molecules will have an easier time penetrating. And that assumption would be correct. The size of a gas molecule, or the kinetic diameter, is a key factor in how easily it penetrates a coating. The smaller the gas molecule, the easier and faster it can permeate through a coating. When harmful gases combined with moisture penetrate a conformal coating, they can cause massive corrosive damage to the board. We see a few harmful gases highlighted in this chart: fluorine gas, sulfur dioxide, carbon dioxide, hydrogen sulfide, and nitrogen, along with moisture. As all of these other gases have a greater kinetic diameter than moisture, a coating effective in blocking moisture will also be effective in blocking the other corrosive gases. That's why AIT conformal coatings can prevent more corrosion than other conformal coatings, by blocking the diffusion of these corrosive gases and moisture. Many industrial applications are sensitive to corrosion from these harmful gases. Here we see images of corrosion of electronics protected by a silicone-type conformal coating and an ultra-thin layer of coating. These were taken from a study on various coatings and their performance in an environment where corrosive gases were abundant. Silicone-type conformal coating was found to have the worst protection. Surprisingly, this ultra-thin coating was found to have the second worst among all the coatings tested. With advancements in technology, sophisticated electronics are at a particularly high risk of reliability problems and failures caused by ionic migration. Electronics operating near the sea are under a greater threat from ionic contaminants than we see in other applications because of the salts in the air, but it can be a problem in any environment. Even coating on an unclean board could cause issues. As technology advances, there's a drive for everything to be higher and higher frequency and smaller, thinner, and more tightly packed. But the higher frequency of our devices and the closer the leads and components are in proximity to each other, the stronger the electric field that drives the movement of ions through conformal coatings. This can lead to a drop in resistivity of the coatings and even lead to short circuits. Advanced weather aging tests and salt spray testing can be used to determine how well different polymers prevent ionic migration. Fluoroethylene vinyl ether, FEVE, is not a conformal coating, but a polymer used in protection of bridges on the sea. SC7130CC from AIT is also a fluorinated polymer, engineered to equal or surpass the salt spray performance of FEVE for maximum protection of electronics. In fact, aeronautic users have excellent performance reviews for SC7130CC based on RTCA DO 160, the environmental conditions and testing procedures for airborne equipment. Salt spray testing is beyond the traditional protection tested by IPC CC 830C qualifications, but it's an effective test to distinguish whether a conformal coating is adequate to protect your electronics in environments near the sea. So interfacial stress considerations are always something carefully considered by AI Technology, Inc. Not just in conformal coatings, but across electronic and microelectronic applications. Stress considerations are a key for long-term reliability. No matter how much protection a coating provides, if it cracks or if it delaminates, it's not going to be effective. I bet there are those out there right now in the audience who have applied a heavy coating of acrylic and seen the results caused by interfacial stress. CTE mismatch between the coating and the board is a main culprit of stress. Just check out the CTE difference between typical acrylic and the PCB. With temperatures below the curing temperature of the coating, the stress is compressive. The coating shrinks more than the board. It can cause delamination from the printed circuit board, especially at sharp corners or along edges. Even worse, if the part is thin, it can cause warpage or even break the part after many cycles. With temperatures above curing temperature, tensile stress will be induced. This can cause cracking or delamination of the coating, rendering it useless no matter how much protection it supposedly provides. And naturally, the stiffer the coating, the greater the stress will be. In some cases, thousands of PSI are induced in stress. Stress concentration points usually occur at sharp interfaces. Large circuit boards will have even more problems because the differential in expansion between the coating and the board will be even greater. And if the board has multiple high-profile components, it's going to cause corresponding points of stress concentration. Since no coatings out there can match the CTE of the boards, your coating needs to be able to stretch. Highly flexible or stress-free products have always been an expertise of AI technology. And we've continued this tradition with our conformal coatings. Coating method can have a real effect on the cost and the convenience of using a particular conformal coating. Parylene has high performance, but it may be limited due to cost and the specialized equipment needed to apply it. Most engineers and manufacturers would like to have something with higher performance, like Parylene, but they compromise for acrylic because it's cheaper and easy to apply. The ideal conformal coating would offer the highest level of performance, but with the ability to apply with standard coating methods like spraying it on, brushing it on, or dip coating the part or the board. Now let's take a look at two new AIT products. AIT's two new coatings were engineered from the beginning to go beyond the IPC standards and begin a new generation of conformal coating for the needs of today's electronics. They're not just new products, they're each part of an entirely new type of conformal coating. CC7130 PRTC is a modified ethylene type, and SC7130CC is a fluorinated polymer type. They were carefully designed to balance all of the attributes needed in today's conformal coatings. They're hydrophobic with low water absorption. These coatings were molecularly engineered to meet the challenge of combining two important and sometimes seemingly contradictory properties. They have high flexibility and can stretch, but with small pore size. This way, the coating has a superior gas and moisture barrier, but won't crack or delaminate during difficult temperature cycling. AIT coatings have excellent adhesion. Even under temperature and humidity cycling, AIT coatings do not delaminate from the board and show no bubbles, pinholes, blisters, cracking, or other issues. We see the insulation resistance across a coated board does not change, even when subjected to temperature and humidity cycling. The water molecules are not able to displace CC7130 PRTC or SC7130 CC, so we see no change in resistance. On the left-hand side of this slide, we can see a silver foil under microscope. The top image is uncoated. The bottom image is after being coated with AIT's CC7130 CC and then a 10-day flour of sulfur test. The sample keeps its same high gloss and smooth appearance. So the flour of sulfur test is used to examine the susceptibility of test articles to sulfur-based corrosion. It was originally developed to test the porosity of metallic coatings. We can see that a sample coated with AIT conformal coating shows no change after 10 days of the humid sulfur test, where other conformal coatings can't provide the same level of protection. We've received requests and feedbacks for AIT coatings. The moisture blocking properties compared to other coatings are often a main point our customers make. These coatings are independent lab certified to pass the standards of IPC CC 830C. For more information about these materials, their properties, and how you can use them in your application, please contact us. Thank you. Thank you, everyone. That is the end of our presentation.
Thank you, Robert. That was a very interesting presentation. For those of you out there, these products would be available through AIT. For smaller quantities, you may check our online store. AI Technology also offers great products used in the manufacture of advanced electronics. That would be thermal interface materials, adhesives, specialty adhesives, die-attach adhesives, electrically and thermally conductive products. We do have some questions. If anyone has some, you can present them in the question and answer. Right now, I have one question I'm looking at. How do you prevent bubbles, pinholes, and foam? Right now, that's a pretty easy question to answer. Its formulation is such that you should not have those issues typically. You may see some if there are issues such as non-cleanliness of certain areas on the board. But if you would have any of these issues, you could contact AI Technology Technical Support, and we would certainly help you through that. Any other questions? I know one question is your presentation available online after the meeting? Yes, it would be available. You can certainly contact one of us if you'd like to have it. I think our technical people would be able to help out with that as well after the webinar. Another question comes up. What are the differences between the two products, CC 7130 and the SC 7130 products? Could I ask my technical support people to pop on for this particular question?
Sure. Can you hear me? Yes, the CC7130 PRTC is engineered as a modified ethylene polymer. So it is non-polar towards non-polar area. So it's slightly different from the SC7130 CC, which is slightly more polar than the CC material. So typically, for some application, we might recommend more polar material. Sometimes we might recommend less polar material. For example, if you are facing an application environment such as automotive electronics that might see, for example, petroleum-based solvent and so on and so forth, in that case, we typically will recommend SC7130-CC. If you're more towards the application where you have a lot of immersion in water or high exposure to water, in that case, CC material or CC7130 PRTC might be more suitable. So it really depends a little bit on the application environment, even though both material perform roughly the same, exposed to the same different environment, but because of the particular working environment that you might have these products in, there might be some preference over the others.
Okay, thank you. Another good question comes up. Are these products UL approved? I know that part of the IPC process involves some flammability testing. If you have additional questions about the UL approval, please be specific. Also, I don't know if our technical support wants to address the UL approval and where we stand with the UL based on the IPC standard.
Yes, based on the IPC standard, is for the coating is self-distinguishing very quickly, so therefore it's almost like a V0 rating.
Okay, thank you. Another good question has come up. Are these solvent-based, and if there is any dilutant needed to reduce the viscosity? I'm going to say yes and no, but technical support, could you possibly?
The coating material that we sell domestically in US market will be shipped with fully solvent dissolved solution that you will be able to spray, dip, or brush coat. We do not recommend much additional solvent. Also, only the recommended solvent should be used. In this case, if for foreign shipping, we actually have a format called solid format, which is basically we extracted the solvent. So when we ship out, we'll be bottled with the solid in it. And then the local situation, for example, if you're in Taiwan, you can buy the solvent that we recommended. You re-infuse it in, so it will reconstitute itself as a coating. So those are because of the shipping costs and being that you have solvent, shipping is very expensive. So for outside of the United States. So.
Okay, going back to the UL approval, the person involved asked if this meets the UL 994 VO.
Yes, it meets the, but because it's coating, so it's measured differently, but it's equivalent to a V0. Yes, we can give you the report on that aspect.
Mm-hmm. Yes. Okay. Again, going back to the solvent and application, I don't think that you would necessarily need a solvent to allow for easy spraying. The materials are designed so that the spraying, requirements are typically met, but there are different spray apparatus, spraying types of equipment. Again, we would work with you to meet these particular meet the particular application. Okay. Let's see. Another question about pricing. The pricing certainly is consistent with many conformal coatings, but what we know is that based on coverage area and thickness and whatnot, our material should be actually more cost effective in doing its in getting you a moisture barrier, moisture proof material. The nice thing is that as Robert highlighted, not only do we meet very good moisture penetration, but we also meet and make a very good chemical and gas barrier to prevent other damages that might be causing you problem. Let's see. The gentleman asks here, a microscope is a spot check measurement. Have you scanned the entire sample surface to ensure the thin film coating? The microscope is a good spot check measurement. Have you scanned the entire sample surface to ensure the thin film coats the entire surface uniformly? Technical support, would you?
Yes, of course. When we are outgoing QC test includes 3 parts. Of course, the viscosity, and then we also have a coating requirement onto a very most difficult substrate. In this case, aluminum foil on both sides. Aluminum foil. Aluminum foil is, probably very difficult to adhere to substrate. So we make sure that there's uniform easy spread on both sides easily. And of course, when we also take that and take a look at the microscope, and the material, of course, are also fluorescent and the UV. So we also examine that as well to make sure that it can be easily seen. And to supplement the thought on the coating, the material itself is engineered to provide a one-pass coating roughly around 10 micron. The testing done by the independent lab is actually in the 30-35 micron area, which is the same thickness requirement for parylene, rather than typical requirement for acrylic will be like 75 microns and beyond. If it's silicone, will be even more, like 200 micron and beyond. So therefore, the coating thickness requirement actually quite thin, and therefore it can be we are engineering it to be useful in even very tightly packed component with component and pitches being closed. So the viscosity has suggested to be stable in those conditions. If any dilution, we don't recommend anything more than 10-20% dilutions. But in any case, in our materials typically already engineered for high volume production used by spray.
Okay, and also as a follow-up, the gentleman does ask, does it contain any UV luminescent for checking purposes? Yes, it does. That is specifically one of the IPC requirements. If you, Robert, were to go back a few slides, that is something that they test for. We actually, receive the pictures in the IPC test report, and it's not the IPC testing, it's a third party doing the IPC standard test, and they actually do that. Let's see, which one is it? The thickness measurement on glass plate under white and UV light must have uniform appearance and consistency. The third item down, on plate glass under UV light, coating must fluoresce under UV black light, typical wavelength. So yes, it does. And from firsthand knowledge, it does do a very, very it does present itself very, very well. So you can tell your coating. It kind of gives you an idea of the thickness as well. Okay. Let's see. Are the AIT coatings transparent and optically smooth to allow their use over high-powered LEDs having silicone lenses, and are they light fast, non-yellowing? Could I ask technical services?
Okay, there are 2 products here. The SC7130 CC is color fast, is fluorinated polymer. It's also very good transparency coating on any substrate. The CC7130 PRTC is also transparent, but less so. It's a little bit more on the translucent side, but nonetheless also transparent to be able to see. So for optical devices, we recommend using SC7130-CC. And LED application has been actually improvements in some of our customer, and is actually used in those outdoor display and so on and so forth.
Yes, as technical support mentioned, there has been some large displays coated with the materials. Another question coming in: are these heat or room temperature cured system? Robert, would you like to answer that? Come back in and help us out.
Okay, sure. So these are sprayed, brushed, or dip on, and they will air dry. And so, yes, it's curing at room temperature when the solvent dries.
Okay, they are rather rapid drying, air drying. So you would typically spray this in a moving air environment, one so that the solvent doesn't affect too many people. Let's see, a question comes in that is, can you suggest any safe solvent to remove the coating from PCBs? I'm going to have to say, what do you mean by safe? But my technical support people may give us some suggestions on solvents.
Okay, AIT product also was engineered to be rather innocuous in terms of safety. It's actually quite easy to use. Its rating is 120, 1 being health, meaning it's like IPA. IPA is rated as 1 as well. 2 meaning fire. Fire, typically IPA is rated as 3. We are rated 2 in this particular case. And as far as for removal, because like we just mentioned before, one type is polar, one type is non-polar. So different material, different type will have different recommendation for solvent removal. Typically, we will recommend using the same type of solvent that we use. So it will be in our MSDS as well. But other solvent with similar polarity might also work. That's how easy it is.
Okay. Here's a good question. Will it be able to adhere to PCB with rosin flux contamination? I'm going to take the first stab at that and say, because I've faced it with a particular application on a PC board, there are some rosin fluxes that may cause some interference. Cleaning is typically required, I think, in front of any conformal coating, and certainly for any adhesive projects, applications, you would probably want to clean. Can my chemist add a few more? Because I think I spoke to you once 2 years ago about rosin fluxes and how they would interfere with our conformal coating.
Okay, as you know, rosin is somewhat of a polar type material. Removing contaminant from rosin is not necessarily because of adhesion problem. It's more that rosin is ionic, with origin treated with some ionics anyway. So you really want to remove it if you could. But if you really cannot remove it, and it's not as critical for you in this case, both of these materials are actually quite forgiving in terms of coating adhesions on different variations of substrates. So that's why when we tested on aluminum foil, those 1 mil aluminum foil they can buy anywhere, because those are machine rolled that is difficult to bond to in most cases. Both of the material has to pass those tests, that it has to bond to both sides and consistently. But if you really talking about something that really you cannot clean too well, it's really dirty, then CC7130 PRTC will be better solution. It's much more non-polar, much easier to spread, and much better adhesion to the most contaminated surfaces.
Okay, thank you. Did we answer the question about safe solvent for removing the coating from the PC board? I'm going to think that maybe this is for rework possibility, but a suggested solvent for removing the coating?
Yes, I think I'll do that, but let me emphasize again. If you're going to, let's say you want to remove CC7130 PRTC, we recommend a solvent called anisole. Anisole is rated as 120 solvent. So you can use it easily anywhere, but if you cannot find such a solvent locally easily, you can use mineral spirits of similar solvent like that. Might take a little bit longer time, but nonetheless, it will work equally well. And if you want to remove the SC7130 material, we recommend solvents such as acetone MEK type of solvent. So those users use Q-tips and use just basically rub on those areas that you want to get rid of. It might take a little bit of time, but nonetheless, it can be removed quickly.
Okay. I have another question has come in, and it is, how thick should the SC7130-CC be for waterproofing to IP67 standards? How thin can it be for this purpose? IP67, is that the continuous submersion? I'll ask, but can our technical people possibly?
I don't think 67 is continuous immersion. It's basically splashed type of requirement. Basically, one coat of the material, both type will be able to meet those requirements, even though that will mean roughly 10 micron. Typically, recommendation is, of course, if 10 micron is adequate in most cases, but you should test against your actual use. For best performance, of course, 2 coat will be best. In the sense of 2 coat being the best, meaning if your 1 coat machine might not be completely covering every angle, the second coat might help you to get to those areas. So that's why typical industrial large volume recommendation, 2 pass will be always better than 1 thick coating pass.
Okay. I'm just looking here to see if I can find any other questions. I hope we've answered all of your questions. I know we've had a very good questions. Again, any type of coating that is going over a PC board is going to have the same issues. You do need a clean PC board. You do want to have a fairly clean environment so that you're not spraying and contaminating your coating with airborne contaminants. But if that's the end of the questions, I will say we will end this in approximately 2 minutes, as I would again like to thank you all for attending and stopping in to visit with us. We've all been fighting this COVID epidemic as everyone else has been, but I hope this has helped you today, and maybe you can stop back, talk to one of us at AI Technology, and we could work with you on an application. Robert, did you want to say anything?
Yes, I just want to thank everyone who attended, and I want to thank Maurice for emceeing this event and our technical team for standing by to answer some questions. And I hope that we hear from all of you and we can work together on some conformal coding applications.
Okay, thank you.